This is a binomial probability distribution problem. Let us read it. It has been observed that 2% of the products produced by a certain factory are defective. What is the probability that in a randomly selected sample of 15 products, letter A, exactly one is defective, and letter B, no more than 3 are defective? We are going to use this binomial distribution formula. P of uppercase letter X is equal to lowercase letter x is equal to n choose x times p raised to x times q raised to n minus x is equal to n factorial over x factorial times n minus x factorial times p raised to x times q raised to n minus x. In the formula, the uppercase letter X here means random variable X. N means number of trials. X means number of successes among n trials. And P means probability of success. Q means probability of failure. N choose X is a combination formula you can see in algebra book as NCR. This is equal to n factorial over x factorial times n minus x factorial. In the problem, n is equal to 15. P is equal to 2% or 0.02. And Q is 1 minus P. So our Q is 1 minus 0.02 and 1 minus 0.02 is 0.98. Let us solve letter A. Exactly 1 is defective. So we are going to solve for the probability that exactly 1 is defective. So the probability that x is 1 is equal to, just substitute 15 for n, 1 for x, and then 0.02 for p, and 0.98 for q. So this is now equal to 15 choose 1 times the 0.02 raised to 1 times the 0.98 raised to 14. 14 because n is 15 and then x is 1. So 15 minus 1 is 14. Now, 15 choose x is equal to 15 factorial over 1 factorial times 15 minus 1 factorial and then times this times the 0.02 raised to 1 times 0.98 raised to 14. This is now equal to 15 factorial over 1 factorial times the 14 factorial times 0.02 raised to 1 times 0.98 raised to 14. Using our calculator, we are going to get 0.22, 60, 92, 58. Letter B. Let us now solve for the probability that no more than 3 are defective. The numbers that are not more than 3 are 0, 1, 2, and 3. 3 is not more than itself. So we are going to solve for the probability that x is 0, the probability that x is 1, the probability that x is 2, and the probability that x is 3. Let us write first the formula. In the formula, we are going to substitute 15 for n, 0 for x, 0.02 for p, 0.98 for q. So we have now the probability that x is 0 is equal to 15 choose 0 times 0.02 raised to 0 times 0.98 raised to 15 is equal to 15 choose 0 is the 15 factorial over 0 factorial times 15 minus 0 factorial times 0.02 raised to 0 times 0.98 raised to 15. This is now equal to 15 factorial over 0 factorial times 15 factorial times 0.02 raised to 0 times 0.98 raised to 15. Using a calculator, we are going to get 0.7385691. Let us write the formula. In the formula, substitute 15 for n, 1 for x, 0.02 for p, 0.98 for q. The probability that x is 1 is equal to 15 choose 1 times 0.02 raised to 1 times the 0.98 raised to 14. 14 because 15 minus 1 is 14 is equal to 15 choose 1 is equal to 15 factorial over 1 factorial minus 15 minus 1 factorial. Then times 0.02 raised to 1 times 0.98 raised to 14. This is now equal to 15 factorial over 1 factorial times 14 factorial and then times 0.02 raised to 1 times 0.98 raised to 14. Using a calculator, we are going to get 0.22609258. Let us write the formula. In the formula, substitute 15 for n, 2 for x, 0.02 for p, 0.98 for q. The probability that x is 2 is equal to 15 choose 2 times 0.02 raised to 2 times 0.98 raised to 13. 13 because 15 minus 2 is 13 is equal to 15 choose 2 is the 15 factorial over 2 factorial times 15 minus 2 factorial and then times 0.02 raised to 2 times 0.98 raised to 13. This is now equal to 15 factorial over 2 factorial times the 13 factorial times 0.02 raised to 2 times the 0.98 raised to 13. Using a calculator, we are going to get 0.03229894. This is the formula. Substitute 15 for n, 3 for x, 0.02 for p, and 0.98 for q. The probability that x is 3 is equal to 15 choose 3 times 0.02 raised to 3 times 0.98 raised to 12, 12 because 15 minus 3 is 12, is equal to 15 choose 3 is the 15 factorial over 3 factorial times 15 minus 3 factorial times 0.0 raised to 3 times 0.98 raised to 12. This is now equal to 15 factorial over 3 factorial times 12 factorial then times 0.02 raised to 3 times 0.98 raised to 12. Using a calculator, we get 0.00285637. We are solving for the probability of no more than 3 defectives. So the probability of x is less than or equal to 3, or the probability of x not more than 3 is equal to the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3. The probability when x is 0 is 0.7385691. The probability when x is 1 is 0.22609258. The probability when x is 2 is 0.0322989.4, and the probability when x is 3 is 0.00285637. Then we add all these. The sum is 0.99981699. So the probability when x is less than or equal to 3, or the probability of no more than 3 defectives is equal to 0.99981699.